Have you ever wondered what makes Siri answer your questions or how Google predicts your search queries? This is the magic of artificial intelligence. Artificial intelligence, or AI, is the simulation of human intelligence processes by machines, particularly computer systems. These processes include learning, reasoning, problem-solving, perception, and even language understanding. The significance of AI is immense. It has the potential to revolutionize every aspect of our lives, from healthcare and education to entertainment and transportation. But AI is not a monolithic entity. It is typically categorized into two types: narrow AI and general AI. Narrow AI refers to systems designed to perform a narrow task, like recommending songs on Spotify or predicting weather. On the other hand, general AI, also known as AGI, refers to systems that possess the ability to understand, learn, adapt, and implement knowledge in a broad range of tasks, much like a human being. However, AGI is still a theoretical concept and doesn't exist in the practical world yet. The journey of AI has been a roller coaster ride. It all started in the 1950s with the dream of creating machines that could mimic human intelligence. Over the decades, the field has seen many ups and downs, from the initial excitement in the 50s and 60s to the periods of disillusionment in the 70s and 80s, and then the resurgence in the 90s with the advent of machine learning. Today, we stand on the cusp of the AI revolution, with advancements in machine learning and deep learning driving rapid progress. In essence, AI is not just a buzzword, it's a revolution that is reshaping our world. As we delve deeper into the world of AI, we'll explore the basic concepts, popular algorithms, and real-world applications that make this field so fascinating. So buckle up as we embark on this exciting journey into the world of artificial intelligence. AI is not just a buzzword, it's a revolution that is reshaping our world. Machine learning is the heart of AI. It's the process that enables machines to learn from data. By learning, we mean the ability to improve at tasks over time. But how does this happen? Well, it all begins with the fundamental concepts of machine learning. First, let's consider supervised learning. Just like a child learns under the supervision of a teacher in supervised learning, our machine learning model learns from labeled data. Here, labeled means that each example in the dataset comes with a corresponding answer or label. The model uses these labels to understand patterns in the data and, eventually, make accurate predictions. Next, we have unsupervised learning. This is like leaving a child in a room full of toys and letting them discover and learn on their own. Here, the model is given unlabeled data and must find patterns and relationships within the data itself. Then comes reinforcement learning, a concept inspired by behavioral psychology. Think of it as teaching a dog new tricks. The dog doesn't know the trick initially, but with consistent rewards for getting closer to the desired behavior, it eventually learns the trick. Similarly, in reinforcement learning, an agent learns to perform an action based on reward or punishment. Now, let's breeze through some common machine learning terminology. Features are the variables or attributes from the data that our model learns from. For instance, if we were training a model to predict whether an email is spam or not, features could be the words in the email's length, or the time it was sent. Labels are the answers or outcomes that our model aims to predict based on the features. In our spam example, the label would be whether the email is spam or not. Finally, a model is the result of training a machine learning algorithm with data. It represents what the machine has learned and is used to make predictions. Machine learning is the tool that makes AI smart, enabling it to learn from experience. And that's just the beginning. There's a whole world of machine learning to explore. So let's keep going and delve deeper into this fascinating field. Algorithms are the building blocks of machine learning. They dictate how machines learn from data. Starting off, we have linear regression, a simple yet powerful algorithm. It's all about finding the best fit line that can predict a continuous outcome. Think of it as trying to predict the price of a house based on its size. The bigger the house, the higher the price, right? Linear regression helps us understand this relationship. Next up is logistic regression. But don't be fooled by its name. It's not a regression algorithm but a classification one. It's used when the outcome is binary, like predicting whether an email is spam or not. It calculates the probability that a given data point belongs to a certain class. Then we have decision trees, which are all about making decisions. They split the data into subsets based on different conditions, creating a tree-like structure. It's like playing a game of 20 questions to predict an outcome. Random forests take the decision tree concept to the next level. Imagine a forest filled with decision trees, each with its own prediction. The forest then votes to decide on the final outcome. This approach helps to improve accuracy and control over fitting. Support vector machines, or SVMs, are another classification algorithm. They work by finding a hyperplane that best separates the classes in the data. It's like drawing a line in the sand to separate two teams playing a game. Finally, we have neural networks inspired by the human brain. They consist of layers of interconnected nodes or neurons. Each layer learns to extract features from the input data, and together they can learn complex patterns and make predictions. They are particularly useful for tasks like image and speech recognition. In the grand scheme of AI, these algorithms are not the be-all and end-all, but they are the starting point, the foundation on which more complex systems are built. Understanding these algorithms is like learning the alphabet before writing a novel. These algorithms are the key to unlocking AI's potential. Deep learning takes machine learning to another level, enabling machines to mimic the human brain. It's a subset of machine learning, but what sets it apart is its use of artificial neural networks with multiple abstraction layers. These layers help to interpret data in a more complex and nuanced way, much like our own cognitive processes. They enable machines to process data in a hierarchical manner, which is crucial when dealing with high-dimensional data. Now let's talk about neural networks, the backbone of deep learning. They take inspiration from the human brain with interconnected nodes or neurons that process and pass on information. They're structured in layers, an input layer to receive data, an output layer to make a decision or prediction, and in between them, hidden layers that do the heavy computational lifting. The more hidden layers, the deeper the learning, and the more sophisticated the tasks the network can accomplish. There are various architectures of neural networks, each with its own strengths and uses. Convolutional neural networks, or CNNs, are typically used in image processing tasks, thanks to their ability to handle spatial data. They're the reason machines can now recognize faces and objects in images. On the other hand, recurrent neural networks, or RNNs, excel in tasks involving sequential data, like understanding the meaning of a sentence or predicting the next word in a text. But how do we implement these complex structures? Enter TensorFlow and PyTorch, two of the most popular frameworks for deep learning. TensorFlow, developed by Google Brain, is known for its robustness and broad adoption in both academia and industry. PyTorch, on the other hand, is praised for its simplicity and ease of use, especially when it comes to building dynamic models. Deep learning, with its neural networks, sophisticated architectures, and powerful frameworks, is revolutionizing technology. It's enabling machines to understand and interpret the world in ways we could only dream of a few decades ago. From voice assistants understanding our commands, to self-driving cars interpreting road scenarios, to algorithms generating art and music, deep learning is pushing the boundaries of what machines can do. The NLP is the technology that allows machines to understand human language. Imagine the power of a computer being able to comprehend and respond to natural language, just like a human does. That's the magic of natural language processing, or NLP for short. It's all about teaching machines to understand, interpret, and generate human language. Now, how does it work? Techniques like tokenization, which breaks down text into individual words or phrases, and stemming and lemmatization, which reduce words to their root form, are used to process language data. NLP is used in various tasks like sentiment analysis, which determines the emotional tone behind words, named entity recognition, which identifies people, places, and things, and machine translation, which automatically translates text from one language to another. And then we have pre-trained language models like BERT and GPT, which have revolutionized NLP, making it possible for machines to understand context, sarcasm, and even generate human-like text. NLP is bridging the gap between humans and machines. Computer vision is the science that allows machines to see the world. It's a fascinating field that combines the power of artificial intelligence with our own visual understanding of the environment. So, how does it work? Computer vision relies on various techniques such as edge detection, feature extraction, and image classification. These techniques allow machines to identify objects, segment images, and even generate new ones. Imagine a robot navigating a room or a security system recognizing a face. That's computer vision in action. There are many tools that help facilitate this process. For instance, OpenCV, a library of programming functions, is widely used for real-time computer vision. On the other hand, TensorFlow, a machine learning framework developed by Google, offers modules designed specifically for computer vision tasks, making it easier to build, train, and deploy machine learning models. To put it simply, computer vision is giving machines the ability to perceive and understand the visual world. A reinforcement learning is the future of AI, where machines learn by trial and error. It's a fascinating branch of machine learning where algorithms learn to make decisions by interacting with an environment. Picture it as a game, where the player or the agent learns to make moves or actions in an environment to maximize its rewards. The agent starts off by exploring, taking random actions, and learning from the outcomes. As it interacts more with the environment, it learns which actions lead to rewards and which ones don't. It then starts to exploit this knowledge to make better decisions. Popular reinforcement learning algorithms, such as Q-learning, deep Q networks, and policy gradients, help in guiding this learning process. Q-learning, for instance, uses a table of Q values for each action in each state to determine the best action to take. Deep Q networks and policy gradients, on the other hand, use neural networks to estimate Q values or directly learn the policy. Reinforcement learning allows machines to learn from their mistakes and successes. AI is powerful, but it also raises important ethical questions. As with any significant technological advancement, artificial intelligence brings with it a host of ethical considerations. One of the most pressing concerns is algorithmic bias. Algorithms are designed by humans, and as such, they can inadvertently inherit our biases. This can lead to skewed results, unfair treatment, and discrimination. For instance, an AI trained primarily on data from a specific demographic may fail to accurately predict or analyze situations involving other demographics. Fairness, then, becomes a crucial factor. Ensuring that AI systems treat all individuals and groups equally is paramount. This is easier said than done, however. It requires careful planning, rigorous testing, and constant vigilance. Transparency is another core ethical principle in AI. The black box nature of many AI systems can make it difficult to understand how they reach their conclusions. This lack of transparency can lead to mistrust and misuse. It's essential that we strive for AI systems that are explainable and understandable, not just to experts, but to end users as well. Accountability, the fourth key consideration, is about ensuring there's a clear line of responsibility when AI systems make mistakes. When an AI system makes a decision, who's to blame if something goes wrong? Is it the developers, the users, or the AI itself? Clear guidelines and regulations are needed to resolve these questions. So how do we address these ethical issues? How do we build AI systems that are fair, transparent, and accountable? The answer lies in a combination of technical and non-technical approaches. On the technical side, we can use techniques like algorithmic auditing, which involves checking AI systems for bias and fairness. On the non-technical side, we need clear policies and regulations that guide AI development and use. We also need to ensure diverse representation in AI development teams. After all, diverse teams are more likely to spot and mitigate potential biases. In conclusion, while AI holds great promise, we must always be mindful of its ethical implications. Only by addressing issues of bias, fairness, transparency, and accountability can we ensure that AI benefits everyone, not just a select few. Ethics in AI is crucial to ensure that the technology benefits everyone. AI is not just a theoretical concept, it's a practical tool that's transforming industries. Indeed, every sector, from healthcare to finance to automotive, is harnessing the power of artificial intelligence. In healthcare, AI is used to predict diseases even before symptoms arise, offering a new dimension to preventive care. In finance, it's revolutionizing the way we manage money, with robo-advisors providing personalized investment advice. The automotive industry is also not left behind, as self-driving cars are no longer a figment of our imagination, but a reality we're gradually embracing. Case in point is Waymo, a subsidiary of Alphabet, that's making strides in autonomous vehicle technology. In the retail sector, AI is improving customer experience with personalized recommendations and virtual fitting rooms. On the environmental front, AI is helping us combat climate change by optimizing energy usage and predicting weather patterns. AI is more than just a technology, it's a tool that's reshaping our world. The best way to learn AI is by doing. Immersing yourself in practical projects is a fantastic way to apply the theoretical knowledge you've gained so far. Let's touch upon some of the hands-on projects you can dive into. First, you might consider building a predictive model using machine learning algorithms. This could involve predicting stock prices or diagnosing diseases from medical images. Then, there's the exciting realm of natural language processing. Here, you could create a sentiment analyzer or a chatbot. Deep learning with its powerful neural networks offers countless possibilities. You could build an image classifier or even explore the generation of new images with generative adversarial networks. In the field of computer vision, projects might involve object detection or facial recognition. Finally, reinforcement learning projects could have you creating your own intelligent game agent. These are just a few examples. The possibilities are truly endless. By working on projects, you can truly understand the power and potential of AI.